Have you ever found yourself in a situation where you had to pass a physical object down a long line of people?
Oh, like a really heavy backpack or something.
Yeah, exactly. A heavy backpack. Or even, just a singular piece of paper. But you have to pass down a line of like 20 different people just to get it to the one person at the very end who actually needs it.
Right, which means you are forcing everyone in the middle of that chain to handle something they have absolutely no use for, simply because they, you know, happen to be standing in the way of the destination.
Exactly. Every single person has to stop what they're doing, take the item, hold it, alter their own workflow, and pass it along. And if someone drops it or if the destination suddenly changes,
The whole logistical system just grinds to a halt.
it totally does. So today, we are taking a deep dive into a developer's journal that tackles this exact kind of logistical nightmare. But, in the architecture of a code base, we are looking at part 214 of Ang's notes on Haskell programming.
Yeah, and on the surface, this entry is, it's a technical log about a specific coding refactor for an ebook generation tool. But if we pull back and look at the underlying mechanics, it actually serves as a masterclass in system design.
Which is why we wanted to cover it, because the core conflict in these notes is really universal.
Definitely. We are going to explore how a very common, tedious headache in coding leads to this really powerful structural solution, and how that solution unexpectedly sparks a massive philosophical debate.
Right, a debate about how we write, read, and communicate complex logic. Even if you don't write in Haskell, this is about the eternal battle between trying to be clever versus trying to be clear.
And that battle starts with the specific headache Ang is facing in the architecture. In the journal, Ang identifies numerous instances of this anti-pattern known as parameter drilling, or you might know it as manual-dependency-injection.
Okay, parameter drilling. Let's really solidify this for everyone listening. Going back to our earlier thought experiment, imagine you are managing a massive factory floor.
Okay, I'm picturing it.
You have 100 workers arranged in an assembly line building a complex machine. Parameter drilling is the equivalent of forcing every single worker on that line to hold a specific wrench in their non-dominant hand all day long.
Right, so the person installing the electronics,
Holding a wrench,
the person painting the chassis.
still holding the wrench. And all of this just in case the very last worker on the line needs that specific wrench to tighten one single bolt at the end of the day.
That is such a good way to put it, because to understand the severity of parameter drilling, you really have to look at how it physically bloats a program. When you manually pass a shared configuration through every single layer of your application, you are destroying the cleanliness of your code.
Because everyone is holding the wrench.
Exactly. If function A calls function B, and function B calls function C, and only function C needs access to that data, parameter drilling forces you to add that data to the type signatures of A and B as well.
And that cascading effect is the real danger, right?
Oh, absolutely. When you build a system that way, you create incredibly brittle code. Every single function in the middle of your program is now carrying baggage it doesn't even use.
It makes the code so much harder to mentally parse.
Right, because you have all these variables polluting the workspace that have nothing to do with the actual domain logic that function is supposed to execute.
And maintaining that system becomes a nightmare. If you suddenly realize that the last worker on the assembly line needs a screwdriver instead of a wrench, you can't just hand them a screwdriver.
No, you can't.
You have to go back and rewrite the instructions for all 99 workers in front of them. You're fundamentally altering the blueprints of the entire factory just to accommodate one tool change.
Which is why we need to stop passing the tools through hand to hand. We need a way to completely decouple the environment from the sequence of operations.
And Ang's notes detail how to achieve this, right?
Yeah, using a specific Haskell concept called the ReaderT-pattern. Ang roots this refactored code under a module named xest2ebook.monad.
Okay, before we get into the weeds of the module, we should probably clarify some of the jargon for anyone listening who might be a bit rusty. What exactly is a monad in this context?
Good question. So, in the source, a monad is basically defined as a context wrapper. It's a way to wrap a value or an operation with some extra background behavior.
Like, for example, a maybe monad.
Right. A maybe monad yields either a just value or nothing. It adds the context of potential failure. An IO monad adds the context that this operation is going to produce real-world side effects.
Got it. And the journal highlights a very deliberate technical choice here regarding how that ReaderT pattern is implemented.
Yeah, instead of relying on MTL, which is widely considered the industry standard library for managing monad transformers, Ang opts to use the default transformer library.
The one that comes bundled directly with the GHC distribution, right?
Yeah.
Doing the wiring manually.
Using the default GHC transformers over MTL is this fascinating architectural decision. It really speaks to Ang's broader philosophy. How so? Well, the MTL library gives you a lot of automated magic. It uses complex type classes to automatically infer which environment you are trying to access deep down in your stack. It saves you from having to manually lift operations through different layers.
But that magic comes with a steep cost.
It does. It adds a heavy dependency footprint. And more importantly, when things go wrong in MTL, the compiler errors can be completely opaque. They border on indecipherable.
So by using the vanilla ReaderT from the base transformers package, Ang is trading the convenience of type class magic for absolute explicit control.
Precisely. You have to wire it yourself, but you always know exactly what the compiler is doing.
So if we look at this ReaderT pattern as a solution to our factory floor problem, I like to visualize it as an atmospheric layer.
Oh, I like that.
Yeah, instead of forcing the workers to pass the configuration down the line by hand, ReaderT acts as an ambient environment that encapsulates the whole factory. The configuration is quite literally pumped into the air vents.
That's a perfect analogy.
Yeah.
Any worker inside that building can just reach up and grab the data whenever they need it. And the workers who don't need it,
They just ignore it. They just breathe the air. They don't have to carry the wrench, and it never pollutes their individual workspace.
the shared environment is passed implicitly through the execution context rather than explicitly through the function arguments, which brings up the crucial design question.
Right. If we are building this ambient atmospheric layer, what exactly are we pumping into the air vents?
What are the specific tools we are making globally available?
Yeah.
So Ang defines this application environment in a strictly typed data record called AppEnv. And for this specific ebook generation software, the environment record contains 3 shared fields.
Okay, let's break those down.
First, envargs. This captures the original arguments passed in by the user from the command line interface. It is the initial configuration state.
Makes sense.
Second, NV handle. This is the output handle designated for logging and debugging, which usually defaults to standard error.
Yeah.
And third, onvopen. This is the actual function used to launch the generated ebook file on the host machine, defaulting to a system call process.
Wait, I have to pause here and look at that grouping. Because honestly, throwing those 3 specific things together feels really counterintuitive.
How so?
We are bundling static user commands, an active error logger, and an executable ebook launcher into the exact same record. That feels like packing for a road trip by throwing a steering wheel, a fire extinguisher, and a radio into the same box.
That is a very weird box.
Right. They perform fundamentally different tasks. Why group them into a single AppEnv package?
I get why it looks strange, but they actually share a single critical characteristic. They represent the application's boundary with the messy, impure outside world.
Oh, interesting.
Yeah, because the core logic of formatting and generating an ebook in Haskell is entirely pure. It is just deterministic data transformation. But a purely functional program that never interacts with the real world is useless.
It just heats up the CPU and terminates.
Yeah, exactly. To actually be a useful piece of software, it needs to read the user demands. That's the onvargs. It needs to mutate a system log if something breaks. That's the env handle.
And it needs to trigger the operating system to open a file, which is nvopen.
You got it. The AppEnv record isn't just a junk drawer. It is the formalized interface between the pristine internal mathematics of the application and the stateful reality of the host computer.
Okay, that reframes it entirely. It is the designated sandbox for all side effects. So now that this atmosphere is defined, how do the functions actually reach into the air vents to grab what they need?
Ang creates a custom wrapper to handle this execution context. They define a new type specifically for the application, simply called app.
Let me look at the type signature Ang wrote in the journal because my eyes are crossing slightly trying to parse it.
It is a bit dense.
Yeah, the syntax reads, new type app A equals app, open brace, unapp, double colon ReaderT, AppEnv, IOA, close brace.
Okay, wait, let's unpack it.
Let's break down the mechanics of what is actually happening there. We are taking a record syntax that unwraps the new type, yielding a ReaderT transformer layered over an IO base, returning a generic type A. That is a lot to wrap your head around.
It is, but it's structurally beautiful once you untangle it.
Mhm.
Working from the inside out, the I/O at the base means this program is ultimately allowed to perform real-world side effects and return some value.
Okay, the real-world sandbox.
Right. And then the ReaderT-appEnv layer wrapped around that I/O means that while we are performing those side effects, we always have read-only access to our specific append record.
Ah, I see. And wrapping the whole thing in a new type called app ensures the compiler treats this specific stack as a unique, distinct entity.
Exactly. So any function written under the app type is guaranteed two things.
Yeah.
It can talk to the real world, and it has the AppEnv tools hovering in the air waiting to be used.
So to actually pull those tools out of the air, Ang uses two specific helpo functions native to the ReaderT pattern, right? Ask and asks.
Yeah. The distinction between them just dictates how granular the code's access to the environment needs to be.
So ask, spelled A-S-K, is the blunt instrument. It fetches the entire AppEnv record at once. Going back to our factory metaphor, using ask is the equivalent of a worker putting out their hand and having the entire toolbox drop from the ceiling.
Right. You get the parameters, the logger, and the launcher all at once, which is useful if you are passing the state to a deeply nested subsystem.
But more often, a function only needs one specific piece of the environment to do its job, right?
That is where the plural version, ask, spelled with an S, becomes vital. It takes a selector function as an argument. It basically maps over the environment and extracts only the specified field.
It's the surgical option. You provide it with a targeted request. The worker says, I don't want the whole toolbox, just hand me the hammer. Or in this case, the logger.
And the ReaderT-pattern seamlessly isolates that one variable and hands it over, leaving the rest of the environment untouched. It resolves the parameter drilling problem completely.
Because the tools are instantly accessible anywhere in the stack, but they never clutter the function signatures.
Exactly.
Okay, so we have this atmospheric environment defined, and we have the tools to surgically extract data from it. But having the blueprints for a factory isn't the same thing as having a running assembly line.
No, it's not.
How does Ang actually inflate this atmospheric bubble and set the application in motion?
So the journal outlines an initialization phase, starting with a function called default-env. This takes the raw parameters from the user from the CLI and binds the standard system handles and process runners.
And this populated record is then fed into the primary execution engine, right? A function called runapp.
Runapp takes the core logic you want to execute and the raw user CLI arguments. It builds that global default env and then applies those environment details to all functions inside the app monad.
So when a user double-clicks the software or runs it in production, runapp is the engine that drives it.
But Ang builds a second parallel engine called runapp-with. If runapp is strictly for production, runapp-with exists entirely for development and testing.
How does that work?
Well, instead of taking raw user parameters and building a default environment, runapp-with takes the core logic and a custom AppEnv that the developer manually provides.
Wait, why is the ability to inject a custom environment so vital for anyone listening who designs these kinds of systems?
Because testing functional architecture without a mocking mechanism is incredibly destructive. If you only have the default env, every single time you run an automated test suite, your program is going to try and execute real-world side effects.
Oh, I see. It might attempt to launch 50 actual ebook files on your machine simultaneously.
Or it might flood your server's actual error logs with fake debug messages.
It's like testing the car by driving it through a crowded intersection.
Exactly. By utilizing runapp-with, a developer can pass a simulated environment instead. You can struck an AppEnv where the env handle just writes to a temporary text file in memory.
And the env-open function does absolutely nothing except report that it was successfully triggered.
Right. You can aggressively verify the intricate routing and logic of your application without ever touching the real operating system.
It's a controlled simulator. You verify the behavior completely isolated from the consequences. But looking at the exact code Ang writes for this simulator for runapp-with, we hit a detail that introduces a massive temptation for developers.
We do. And this syntax choice leads directly into the most fiery philosophical portion of Ang's entire journal entry.
It really does. It's the temptation of ADA reduction, right?
Yes, Ang explicitly defines the testing engine like this. Runapp-with action nv equals run reader t, open parent, unapp action, close parent, nv.
Okay, notice the structure there. The variable nv is the very last argument on the left side of the equal sign, and it is the exact same variable placed at the very end of the right side of the equal sign.
And because of how functions operate at a fundamental mathematical level in Haskell, you don't actually have to write it that way. Haskell relies on a concept called currying. Under the hood, Every single function technically only takes one argument. When you see a function that appears to take two arguments, it is actually taking the first argument and returning a brand new function that is waiting to accept the second argument.
Let me make sure I'm tracking the math here.
Hmm.
If the last step of the left side is returning a function that is waiting for an environment variable,
Yeah.
and the core operation on the right side is also returning a function that is waiting for an environment variable, the inputs and outputs align perfectly. The computer already knows what goes there.
You got it. You don't need to explicitly name the environment variable. Because the partial applications perfectly match, you can just declare that the two functions are mathematically equivalent.
So you can drop the end argument entirely.
Completely drop it. Instead of writing that whole long string with env on both sides, you can write run app with action equals run reader T on app action. This is known as point-free style.
Okay, but if the computer perfectly understands the currying, and it saves the developer from having to type redundant variables, why is Ang so strongly against doing this?
Yeah, the journal takes a very hard line against using point-free style here. Ang rejects it because it severely degrades readability for the human beings who are forced to maintain the system later.
Oh.
When you rely on edit reduction, a developer reading the code base 6 months down the line has to mentally calculate the currying. They have to parse the implicit mathematical structure of the types, rather than simply reading the explicit text on the screen.
It's the equivalent of writing a complex instruction manual and intentionally leaving out the direct object of the sentence because you assume the reader is smart enough to infer it from context.
Right, like saying, take the widget, apply the grease, and then install.
Install what? Where? If you know the system, you can probably guess, but why force the reader to expend the cognitive energy to solve a puzzle?
Exactly. And to anchor this argument, Ang pulls in a foundational design principle from a completely different programming ecosystem, the Ada language.
What's the quote?
The journal quotes the Ada philosophy directly, stating, readability is more important than conciseness, and explicit is better than implicit.
Framing it that way really elevates the entire discussion. It's no longer just a debate about syntax preferences. It is a clash between two fundamentally different mindsets in software engineering.
It is. Ang frames this as the divide between industrial Haskell and Academy Haskell.
Academy Haskell being what, exactly?
Academy Haskell is often written to showcase theoretical brilliance. It prioritizes proving how cleverly and concisely you can express a purely mathematical concept using advanced techniques, like point-free style.
It treats code as an academic flex. Look at how few characters I used to achieve this complex transformation.
Exactly. But industrial Haskell, which is the methodology Ang fiercely advocates for, is written for survival. It's written for longevity and team collaboration.
Because in an industrial production setting, minimizing cognitive load for the maintainer is the highest possible priority.
Think about the person reading your module at 2 a.m. during a server outage. They might be a junior developer, or they might be you, having completely forgotten the clever mental gymnastics you were performing when you wrote the function a year ago.
Yeah, in those high-pressure moments, you don't want an elegant mathematical puzzle. You want aggressively explicit, undeniable instructions.
The explicit presence of that trailing ends argument acts as a vital signpost. It instantly communicates the physical shape of the data moving through the system. You don't have to cross-reference type signatures or mentally reconstruct the curried functions.
So zooming out, this journey through Ang's journal covers a massive amount of architectural ground.
It really does.
We started with the physical, logistical headache of parameter drilling, passing that heavy wrench down a line of 20 functions just to get it to the end.
Right.
We resolved that nightmare by utilizing the ReaderT-pattern to create an ambient atmospheric environment, decoupling our configuration from our core logic.
Yep. Pumped it into the air vents.
Then we built the AppEnv record to formalize our boundary with the messy real world and used ask and asks to surgically extract those tools from the air.
We separated our production engine from our testing simulator using run AppEnv.
And ultimately, that led us into a deep philosophical debate about currying, point-free style, and the very nature of how we communicate instructions.
The technical mechanics of Haskell are fascinating. But the real enduring takeaway is that tension between cleverness and clarity.
I want to connect this directly to you, listening right now, because the friction Ang is highlighting extends far beyond functional programming.
Oh, absolutely.
Whether you are architecting a distributed backend system, drafting a critical strategy memo for your department, or even just writing a standard operating procedure for a small team, the temptation to be clever and concise is omnipresent.
It feels intellectually satisfying to be brief.
It really does.
Yeah.
But Aang's application of the Ada philosophy is a powerful reminder that being clever is rarely as valuable as being completely, unequivocally understood by the next person who inherits your work. Explicit clarity is the foundation of long-term sustainability.
It's an incredibly compelling argument for prioritizing the reader over the writer. But it does leave us with a final, somewhat provocative thought to ponder regarding the limits of that philosophy.
Oh, what do you mean?
Well, we've just explored the immense value of explicit readability, the idea that we shouldn't hide our parameters behind mathematical currying or implicit context. But if we follow that logic to its absolute extreme, where does it break down?
You mean taking the explicit philosophy too far?
Yeah. Think about the density of information. If we optimize our systems, our code bases, our internal emails, or architectural documentation to aggressively spell out every single explicit detail.
Refusing to ever take a shortcut or rely on any shared baseline knowledge.
Exactly. At what point does the sheer volume of explicit information actually begin to degrade our comprehension?
Wow, yeah.
If we force the reader to process the explicit label on every single wrench, every single bolt, and every single atmospheric variable, do we eventually drown the critical logic in a sea of exhaustive clarity? Do we eventually lose the forest for the trees?